They're just copying this down right now. Yeah.
I watched one of those videos.
For those of you at home, you missed our talk over the law of conservation of mass. It just says that the reactants that we start with, all those elements, we have to have the same amount of those elements as we do in the product. So the reactants have to match the products in terms of the number of atoms. We do that by adding coefficients. We never ever change subscripts. That sums up what you missed. All right, can I move on? All right. We have 5 examples. Here's the first one. Emery, you want to read it?
Hydrogen reacts with oxygen to produce water.
Hydrogen reacts with oxygen to produce water. Help me out. What do I write? Hydrogen reacts with oxygen to produce water. Hey, let's do my checks. I have an H. Is that a compound or an element? It's an element. I need to check Brinkelhoff. It is. What does that mean? Oxygen, compound or element? Element, check Brinkelhoff. Is it Brinkelhoff? Yes. What do I do? Add it to. Hey, look at H2O really, really quick. Look. Okay, some of you do not like H2O, and I don't quite I understand it, but I don't understand it. Okay, here's my thing. Hey, water, you never have to do anything to it in terms of checking it, because you know that you've known since you were 5 years old, water is always H2O. You don't need to worry about charges, prefixes. You know water is H2O. Okay, just leave it. Don't hurt your brains, because that's what I was seeing yesterday from people that were asking for help. Okay. Cool. Hey, this is where balancing comes in. All of that stuff that we just did was all from Monday or Tuesday. Balancing for you guys, I'm hoping, clicks very quickly. Here's how it works. I want us to first look at how many of each element are on both sides. How many hydrogens are on the left? 2. How many oxygens are on the left? Let's go to the other side. How many H's are on the right? 2. How many oxygens are on the right? Hey, are we balanced? No. If I step on one more thing, I'm gonna. Okay. So yeah, we're unbalanced. I have 2 oxygens on the left, but I only have 1 on the right. This is where we can start adding coefficients in order to fix that problem. Hey, I'm gonna tell y'all this for our class. Technically, if you really wanted to, you could use fractions. Mr. Mead is telling you, don't ever use fractions. Fractions hurt most of your brains anyways, so we're just not gonna use them. We're gonna use whole numbers, okay? Hey, so look, when I say whole numbers, I mean like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc., etc. So looking that I have 2 oxygens here, 1 oxygen's here, which one can I multiply by something to get to the other? The right. What can I multiply the right by? 2, right? If I multiply 1 oxygen times 2, well, then I'll have 2 oxygens. Here's how I write that. Watch. It's a really, really hard process. You ready?
I have a question.
What?
Because in Hess's law, we said that if you add a coefficient, you have to do that every single thing.
That's Hess's law.
Okay, so this is totally unrelated.
Kind of, sort of, yeah.
Please stick it together, please. Just ask.
That's Hess's law.
Remember, ask your question.
Hey, so look, when I add that 2, I change my oxygens, right? How many oxygens do I have now? 2. But what do I also change? My hydrogens. How many hydrogens do I have now?
4.
I have 4. Hey, but look, I have 4 hydrogens here, but how many do I have on the left? 2. So what can I do to the left to maybe fix it to make it 4? Multiply it by 2 like this? No! Be specific here, people.
Just do the hydrogens by 2.
Just this guy. Hey, when I add a 2 here, how many hydrogens do I have now? 4. Are we balanced? Yes. How do we feel so far? I've been told y'all have done this in like 8th grade. Like this should be kind of a recap. We're just gonna be doing a little more complicated reaction. Mrs. Hale.
I know her. I have her number.
Hey, number 2. Hydrogen reacts with nitrogen to produce ammonia, aka nitrogen trihydride. What do I write here? Nitrogen reacts with hydrogen to produce ammonia, aka ammonia trihydride. What?
Hydrogen reacts with nitrogen.
Oh, did I write backward? I'm sorry.
Yes.
For the record, that would make no difference.
Well, I know, I just said.
But for the sake of your brains, and I don't want Reagan to yell at me. Hey, let's do my checks. Nitrogen, am I a compound or an element? I'm an element. What do I need to check? Brinkelhoff. Are we Brinkelhoff?
Yes.
Yes. What do I do? Additive. Nitrogen, compound or element? Element. Check Brinkelhoff. It gets a 2. Bless you. NH3, compound or element? Compound. Check nomenclature. Am I ionic or covalent? I'm covalent. Let's check. I have nitrogen trihydride. Nitrogen trihydride. Am I good? All right, let's balance. How many hydrogens do I have on the left? 2. How many nitrogens do I have on the left? Okay, what?
Did you balance your compound? Because like nitrogen has a -3 charge and hydrogen has a +1, so which
It's
charge?
covalent.
Oh, it's covalent. If we do the ionic.
But even if it was ionic, it'd be -3 and +1, 1, 3.
So it's already done.
Hey, so I have 2 and 2 here. What do I have on the right for hydrogens? How many? I have 3 hydrogens on the right. How many nitrogens do I have? 1. What am I going to do first?
Multiplied by 2.
Multiply what by 2?
Your N.
This or this?
NH3.
So if I added 2 there, hey, that changes my nitrogens. How many nitrogens do I have now? How many hydrogens do I have? Hey, that changed my hydrogen, so I need to come back over to my left and fix them. What do I need to add? 3, where? In front of H2. Do we agree?
Do you have to add parentheses around NH3?
Nope. Am I balanced? How do we feel so far? Pretty easy, right? Okay, let's do another one.
Oh, my back.
Sodium reacts with sodium nitrate to produce sodium oxide and nitrogen gas. Once you do your checks, your reaction should look like mine. Do we agree? Hey, let's look at sodium. How many sodiums do I have on the left? 2. How many nitrogens? 1. And how many oxygens? 3. Do the same thing on the right. What do I have for sodiums? 2. Nitrogens? 2. And oxygens. Are we balanced? No, we need to fix some stuff. It doesn't matter what element you start with. Sometimes there's an easier one. Sometimes there's not. As you practice these and do more and more, you'll be able to find those kind of patterns, okay? So for here, what element would you guys like to start with?
Nitrogen.
Start with nitrogen, okay? What would you want to do to fix my nitrogens?
Multiply the one on the left by 2.
This one or this one? Sodium or sodium nitrate?
Sodium nitrate.
Sodium nitrate. So we're going to multiply sodium nitrate by 2, says Adia. So by doing that, that changes my sodiums. How many sodiums do I have now on the left?
4.
I see 3.
3.
How many nitrogens?
2.
2. And how many oxygens?
6.
6. Hey, that changed a bunch of stuff over here, so now I need to go to the right and fix some stuff. What would you like to fix? There's one here that's easier than the other.
Oxygen.
Oxygen. Why is oxygen easier?
Because you can just multiply it by 6.
Yeah, I can just multiply this guy by 6.
Then it changes the
It's going to change my oxygens. How many oxygens do I have now? 6. How many sodiums do I have now?
12.
So that changed my sodiums
Just change the back. Multiply the normal
by 4. Okay? If I do that by 4, how many sodiums do I have?
12.
I see 4 there and I see 2 there. I see 6 in total. Maybe it's a different number than 4. How many do we need? We need 12. We have 3 right now. What do you say, Grace?
10.
It's going to be 10. We multiply this by 10. Now I have 12 sodiums. Am I balanced? Hey, does everybody see why we multiplied this by 10? Lucy, do you see why I multiplied by 10? How do we feel? Still pretty easy so far? It's like a puzzle piece, right?
Nope. Nope.
Huh?
That's really nice and relaxing.
Sorry.
This is not nice and relaxing. It's like a puzzle.
What's wrong, Hannah?
I'm just
On what part?
or
How?
I get this.
Because
You just add them together. And that's what you get.
Are you talking about sodium oxide? Are you
Yeah,
talking
like
about
why
this
is
too?
there 2 on that sodium and not on the other sodium?
On this one or this one?
The first one.
This one?
Yeah.
Hey, you see how this is just a free element?
Yeah.
If it's an element, check Brinkelhoff. Is it Brinkelhoff? No, so it stays the same. Look at this one. Is it a compound or element? Compound, check nomenclature. Are we ionic or covalent? We're ionic. So what's the charge? No, we're looking at charges. What's the charge of sodium?
1.
+1, right? What's the charge of nitrate, NO3?
Did you say is it nitrate?
Nitrate, yeah, NO3.
Negative number?
Yeah, so when you crisscross these, what's going to happen?
It's gonna just
It's
sit.
going to wash, right? It's both negative or both ones. Look here. Are we a compound or free element? Compound, are we ionic or covalent?
Ionic.
Ionic, what's the charge of sodium?
+1.
+1, what's the charge of oxygen?
-2.
So when you crisscross, 2 will come down here, your 1 will go there. That's where that 2 comes from. Does that make sense?
Yeah.
Okay. Ethan, you want to read the next one?
Pentane reacts with oxygen to reduce carbon dioxide and water.
Yeah. Hey, y'all have no idea what pentane is. That's okay. That was for me. Hey, pentane is a gas that some of you may have smelled before. It's not a very good smell. But it's C5H12. You do not need to remember that. I'm not going to ask you something like that. But we have pentane reacts with oxygen to produce carbon dioxide and water. Take a second and do your checks, see if everything matches up. Do we agree with what I have? Hey, let's try and balance it. Carbon's on the left, question mark? 5. Hydrogen's on the left. Oxygen's on the left. Let's look on the right. How many carbons are on the right? 1. How many oxygens are on the right? 3. Good job. How many hydrogens?
2. Why do you have 2 O's?
Oh, that should not be a 2. Perfect. This is 3.
No, like you have CO.
Oh. Now you're double right, I guess.
So
There we
what's
go.
the other side?
Dude, what was I doing?
You just entered a flow state.
I guess. Entered something.
Entered this.
Where would you guys like to start? Start with carbons, yeah. How do I fix my carbons? Multiply CO2 by 5. By doing that, that changes my carbons to 5. What does that change my oxygens to? I disagree. 11. You have 5 times 2 for 10, plus this guy for 11. Hey, do you say that oxygens right now is at an odd number? Is there anything I can multiply O2 by to get to an odd number? No, because I said we're not dealing with fractions. So, let's try doing the H's. Anything I can do to fix my H's? This guy? This guy? Multiply by 6 on over here by water. That changes my hydrogens to 12. That changes my oxygens. So now I have 10 from here, 6 from here. 10 plus 6 is? 16. Now is there something I can multiply O2 by to get to 16?
8.
How do we feel with that one?
It satisfies my OCD. Like,
Yay. Okay, I got one more.
One more. I don't have one.
What will I eat? Yttrium. Yttrium.
Hey, actually, I have a question about the Roman numeral things.
Okay.
Does that signify the charge or the substance?
Charge. Okay. 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 Okay.
I miss sig figs.
You missed sig figs? Don't worry, when we get to stoichiometry, we'll be doing sig figs all day, every
So
day.
I just miss.
Hey, I'm so excited. We're 2 weeks away from stoichiometry.
No, I'm not.
About to have the time of our lives. Hope you guys like math, because that's all it is. Hey, let's write. I see yttrium 3 chloride. reacts with sodium hydroxide to form yttrium 3 hydroxide and sodium chloride. Once you do your checks, make sure your reaction looks like mine. Oh, somebody get my goldfish.
How dare they? Dang it, that's a parenthesis.
Would you?
What? What?
No,
What?
no, I haven't.
Mr. Reed drove the blue car.
We do.
I just joked.
Matches are themselves
Oh.
Well, then you wouldn't, bro. It's like so 6 years ago.
Ew!
It's in the
What?
middle. COVID was 6 years ago.
The gritty was not, and if it would be like if it was off the
What?
then it would like that would be too.
The gritty was like.
Hey, let's do some checks. Hey, so let's look. Did everybody get YCl3? Did we get sodium hydroxide? Did we get parentheses around hydroxide and yttrium 3 hydroxide?
Yes.
Did we get sodium chloride? Let's work on balancing. How many yttriums are on the left? Question mark. Chlorines. Sodiums. Hey, now pause. Don't do anything further. Look. Hey, I want you to think about some polyatomics can be thought about as packages. Hey, do you see how we have OH right here? Hey, and on the exact opposite side on the same, we still have an OH. It didn't change. We have OH and OH. Don't break those apart. If you have a polyatomic that shows up in both the left side and the right side, don't break them up. Make your lives easy. Leave them together. So here, I'm going to say that we have one OH. Hey, what about on the right side? How many yttriums do I have? How many hydroxides?
3.
How many sodiums? How many chlorines?
1.
Let's balance. Where would you like to start?
Your yttriums are already.
Our yttriums are balanced. That's great. What else? We could do something with the chlorines. What can I fix with chlorines here?
3 NaCl.
We can multiply NaCl by 3. By doing that, that changes my chlorines to 3, my sodiums to 3.
Do a 3 on the NaOH.
Do a 3 on NaOH. That changes my NAs to 3. And my OHs to 3. Why am I balanced?